Hope everyone is very safely and nicely in the food coma after lunch. And so I'm going to do a relaxed talk. Nothing much actionable for your hacking, just some secrets about AI that Web3 doesn't want you to know. So I'm Illia. I'm co-founder of Near Protocol. Previously, I worked for about 10 years in machine learning research and development. I worked at Google Research, leading a team, working on natural language understanding, as well as I developed a lot of the the previous generation machine learning framework called TensorFlow. And with a team of folks who worked on a model called Transformer, which transformed the whole AI space now and pretty much is what T in GPT stands for. And so in 2017, we started an AI company called Near AI, but we had quite a use case for a blockchain needing to pay people, and realized that at 2018, there was nothing on the market that would really satisfy us. And so we pivoted to build Near Protocol. Now, for those who are not familiar, language models are not a new thing. They've existed since 1950s. It's a general statistical model, and it's pretty much, giving some set of words. Can you predict what's going to be the next word, right? And what is the probability? And, you can write out the conditional probabilities of any specific word given the context. And so this, existed for a while. It was a useful tool for, handcrafted natural language understanding. But there's an interesting thing happened in 2013 where the concept of embeddings was introduced. And this is the idea that, normally when we look at words, we see a symbol, right? It's a single thing. And it's really hard to deal with symbols on computers, right? It's really hard to do something with it because it's just a label. And what embeddings introduced is this idea that you can map this symbol into a multidimensional space, right? And now you can do all kinds of math with it. You can compute distances. You can pretty much multiply them to pretty much transform that space based on your needs. And this kind of kicked off a pretty, faster evolution of natural language with deep learning now. And this is actually when I joined Google, switching from statistical methods because I saw this as a really great opportunity of pushing the understanding of how AI understands language. Now, there was the idea of recurrent neural networks, which is pretty simple. You want to read one word at a time, process it, and then read next one. And then after you finish reading, you can either predict next word, translate, answer questions. It was actually pretty reasonably old thing, 1997. And until embeddings, it was kind of hard to use as well. But since 2014, we were all, going at it, doing a lot of research. We have a bunch of papers published about how to use RNNs for all kinds of stuff. Now, the problem was we were sitting all in research and building these cool RNN models. And then there was all the search and translate and other teams who were continued doing fine-tuning with their manual feature engineering. And literally nothing was shipping across the board because all of our models were taking, seconds to process documents. They would pretty much not qualify for latency requirements that product at Google had. And what we were doing in result, because, you do want to launch something and you want to show impact, we would take models that didn't have any understanding of the sequence, right? So imagine all of these words just jumbled. It's called bag of words. And we would try to build a model that would answer questions and do other things just from that. So not knowing anything about the sequence. And it actually worked. We shipped some products. We had model that was answering questions and Google.com without literally understanding the sequence of the words, which is, pretty interesting. But obviously, this is a problem, right? This model should actually understand the sequence. They should, be able to reason about what's going on in the document. And this idea of transformers came from a pretty interesting thought. The thought is, what if we allow each word to pretty much look around the whole document to understand itself, but we do it in parallel, right? We don't read one word at a time, how humans do. We try to do it all in parallel, every single word at the same time, trying to look around the document and see what it means. So to give you an example, for example, for a sentence, cat jumped on the wall, it was tall, it can resolve into cat or a wall, right? And so normally you would read cat, one word at a time, and then at the end you would presumably have a semantic meaning of the whole sentence, and it would be pretty limited because it has a fixed size. And here you have this idea that it can look around and see what are the other words that most probably it's related to, and kind of compose that meaning directly in its own vector for the next layer. And you have multiple layers of this mechanism called self-attention to actually give you resolution and reasoning now around different words and different contexts. The really cool thing is we have parallel computers, and CPUs have multiple cores, but even more interestingly, with GPUs, we have lots and lots of parallel processing. And so you can do all of this at scale in parallel. Pretty much when you read, potentially thousands or tens of thousands of tokens at the same time and process them in parallel, as if you read, the whole chapter of a book at once just by looking at it. And I use this analogy of if you watched movie Arrival, where the aliens talk in a whole sentence at once. This is kind of how we're training machines to read, is you read the whole book at once. So this led, this model was introduced in end of 17, and through the next years, we've seen dramatic increase in the size of the models, and we saw GPT-2, which was an interesting language model, cool toy. Researchers were kind of excited, and then GPT-3 landed, which was this thing actually kind of understands some stuff. And obviously, when OpenAI released ChatGPT, which was 3.5, it really showed that these models can actually do something really interesting. So we have this kind of acceleration that's happening, right? It's happening because these models are interestingly now transcended this limitation that before they were kind of a researcher in a lab. We had models, if you tried Perplexity, we had it internally at Google, right? It was a pretty standard thing you can put together. But it was obviously not production ready. It wouldn't scale. It was too slow. And now we have something that, you as a non-engineer potentially can use to actually communicate with computers, right? We're removing, in a way, this intermediary of a person interpreting, and now have AI models being able to communicate directly, understand semantic meaning of what you're talking about, not just syntactic kind of symbolic programs that you write into it. In a way, it almost starts to understand intents instead of having the execution traces. This is a number reference. Now, just to give you some, secrets for those who are not in AI space, right? So when you think of this, GPUs, for people who've been, playing video games, they think of this chip that sits in their PC. For those who've been mining, Ethereum, for example, and proof of work, you imagine, this kind of specific chips, again, that were used for that. The reality is these are supercomputers. And these supercomputers are stacked with pretty much multiple GPUs, multiple of these parallel processing devices on single motherboard. There's usually 8 that sit on one motherboard. There is small CPU to route some data and connect to internet and provision software. And then these things are actually stacked into racks, and then you have a ton of these racks pretty much in data center. And so this in turn gives you a kind of a supercomputer that you are training these models on or doing inference on. And so the current kind of what's NVIDIA ships is H100s. So you would train GPT 3.5 model for about 3 months on 10,000 H100s. And that's about the cost it will cost you. $64 million is to train GPT 3.5. And this is if you really know what you're doing and everything is working. So that's just to give you an idea of what is the compute behind this, right? This is each GPU, I don't have the right number, but like, some amount of petaflops, 8 of them, and then you have, 10,000 of kind of in a data center. Now, more importantly is, and kind of people really don't talk about this, is these GPUs are interconnected with a specialized connectivity. And when I say specialized connectivity, so we're talking about H100, H200, we're talking about gigabits per second. So if you see this is 900 gigabytes per second, gigabytes per second, is the connectivity between GPUs in those centers. For comparison, your CPU to RAM connectivity, what you have in your laptops, is something like 9 gigabytes. So this is 100 times faster that you can send data between CPU to GPU or to RAM. You can send between 2 different GPUs. Now, as you see, this chart kind of expanded a little bit because they announced a new version at the GTC, and I can't even read that number at this point. This is like 2,000 gigabytes per second, so insane. And so what it means is, like from a developer perspective, you actually have a single GPU that consists of 10,000 actual compute units, and you have this gigantic amount of RAM. So each H100 is 80 gigs, B100 will be 92 gigs. So you have 10,000 of 80 gig RAM devices, and you can pretty much deploy all that kind of RAM. You replicate and everything, but allowing you to have kind of this massive supercomputer. That's really what it is. Like, this is not a GPU that you used for gaming. This is a massive supercomputer devices that cost tens of millions of dollars to deploy for months, right? Like, if you want to buy that, this is like multiplied by 12. So that's kind of the idea. Again, we don't usually talk about this in Web3. We talk, there's numbers in Web3 usually like it's kilobytes per second, right? That's the data availability we have and things like that. This is just interconnect, like literally to send bytes between, right? So switching a little bit gears, right? Okay, cool. We have this like massive data centers that training these cool models. The challenge this is that only big companies now can afford that, right? This is like a massive cost, massive investment. If you need to buy those things usually, right? And so with massive companies, we have a very structural problem, is that it has, huge legal liability for everything they're doing. They have, whatever their ethic and kind of curation teams that like deciding what's going in, right? So this is just kind of to show you, when you're going and using a model, right? And you're like typing happily your query, which car to buy. There is kind of a whole process that happened behind the scene that led to the answer, right? It starts with the data set. Everything that these models know comes from data. And this data is by definition biased. Like, our world is about bias. And like, for those who don't know, in machine learning, there's this idea of it's weights and biases. And kind of that's how models are represented. And so these models are learning bias. And whoever decides what goes into data defines what bias they're learning, right? And this can be, just to give you from my example, right? When we're doing our machine learning, if you scrape internet, on internet there's a lot of conspiracy websites that talk about Barack Obama being born in Kenya. And actually, statistically, if you just scrape internet and don't apply any filters, it will be 50% chance it will say he's born in Kenya, and 50% chance he's born in Hawaii. And so if you're trying to build a model, and it gives you, first of all, it's going to start just flip. If it's like so equal, it will just start flipping based on something else. It will just give you different answers every time. And so you go and you look at data, and you're like, well, this is broken. And you decide to filter out some websites. And so this is where curation happens, right? Like, I, as an engineer, decide like, hey, I don't think this is true, and it's messing up my results. I'm going to filter out a bunch of these conspiracy theory websites. Now, from my perspective, that conspiracy theory. From somebody else's, maybe this is, golden standard. Who knows? But like, the point is, there's a very subjective decision that's happening early on that are not captured anywhere. They're not transparent. They're completely kind of opaque to the result you're using. You have then legal team that comes in and says, we cannot use this like images, or this content is, under copyright, let's remove it. And so now you're missing another piece of the information on internet, and like your model doesn't even know about some things, right? You have a bunch of this also happening, and we've seen this kind of in past months, that this team's also coming in and saying, let's make sure the model will never output this, or, let's make it more diverse outputting, right? We like unbias the bias, right? Which came from training data, which leads to lots of issues. And this is something that I don't know yet somebody doing this, but I'm very much expect this to happen, is that at inference time, right now, it just outputs what model says, but they can reweight this. It can change based on some external condition. For example, somebody paying the company to change the results. And so let's say you go and ask which car to buy, which candidates to vote, and what are the pros and cons. Somebody else can say, well, we think that it should output Hyundai because it's the best car, and we're going to pay for that. And so all the results now always say that Hyundai is the car to buy, which may or may not good, but like that's not what training data said. This is somebody paid for it in the auction. And the thing is, like, ad auctions have a millisecond latency, like 10 millisecond latency, and the output of a token right now is about like way higher than that of a single token. So you can literally run an auction on every single step and have all of the context already in embeddings from the transformer model in it. So it's actually very efficient. Like, it will be the most, production ready. I hope I didn't give anyone bad ideas, but I'm pretty sure this will happen. And so what this leads to is a massive regulatory fight that is unrolling already. This was just like from 3 days of news, just like searching for AI lawsuits. So European media sues Google, OpenAI, New York Times sues OpenAI. Obviously Elon Musk sues OpenAI. Like, it's everybody will be suing everyone. So we're getting into this world of kind of really trying to redefine what kind of legal system and technology working together. And we're familiar with this in Web3, right? This is something that we kind of like in a continuous battle already, because we are introducing something that's operating outside of existing systems. But AI is also transformational in how it works. And it's transforming in a way that will lead to a lot of kind of challenges. So we also have a lot of risks, right? On the regulatory side, like, all of this battle will mean that regulators will try to come in and do something. They'll try to go and do kind of regulation without really understanding technology, and especially the slope of evolution of technology. And so they will lead to approaches that don't make sense. Like, hey, you cannot train models above this parameter size without, having a safety team, right? Without defining what that means. Or you need to KYC now if you're using data center, right? Again, something we are familiar with in crypto. We have a pretty kind of bad state of open source because given the kind of compute requirements and monetary requirements, if you're building open source, you're not being able to capture enough value back to then reinvest into more compute, right? This is what happened, kind of one of the reasons OpenAI stopped open sourcing models is because, hey, we need to make money to invest back into bigger models. And so we don't want to open source. We have this idea that, these models are now kind of can be used to create misleading content, manipulating people, and they're becoming better and better, right? They can literally train to, mimic other people and learn how to adjust and talk about this. And obviously, the big tech companies have the skewed incentives just by nature of, as soon as you reach your target audience, like, and saturated, the only thing you can do to continue showing growth in revenue is increase revenue per user. And to do that, you need to get users to spend more, which means you're manipulating them, you're changing their behavior. So this is all the case for open source AI. This is really kind of the motivation that we need to figure out a way to incentivize open source AI that is on your side. That's not sitting and kind of optimizing for maximum revenue for the user, but actually for the company, but actually it's on the user side and optimizing for your individual benefit and for community's benefit, right? Whatever the community scope is. So there's a whole stack of primitives into decentralized AI that we need, in open source AI we need. that I'll go through, but major kind of buckets are data, infra, and apps. So let's start with data. So there's content reputation, crowdsourcing, data curation, personal data, and many other things. I'll talk about content reputation because there's a kind of this idea that, hey, these language models are able now to interact directly, right? They can convince people, they can influence people, they can actually interact with bureaucracy, with politics. They can, like you can have LLMs that is a political actor that is, going around and convincing people to vote for it. And the thing is, like, all of this is not really LLM problem. It's a human problem. And like we've had all these problems before, like the misinformation existed for thousands of years. It's not like a new thing. Byzantine fault tolerance, right, coming from Byzantine generals, that's where, it's all about misinformation. Now, these tools are making it way more accessible and allowed to do it at scale. And so kind of the solution here is really to use cryptography. Cryptography allows us to have kind of traceability of information. It allows to have this kind of provenance and reputation. And we can now use blockchain to, root the identity of cryptography and allow to have kind of users to understand where information comes from. And to just give you an example, right, this was like a picture with, that was photoshopped. And again, this is not like, it was not, AI wasn't used, I'm assuming. It would be way better if AI was used, but they photoshopped it manually. And so what you want is ability to hover over it and get, who published it, when it would happen, and also community nodes, like what happened with this image. You should, go and ask more what's going on, learn more details, where it came from, what is the other information about it, right? And so you can then go and like validate that this account, right, is indeed like the account you trust as an information publisher, or as a or maybe you don't trust because it is like consistently misinforming from your perspective. So you can build your own kind of trust graph on top of the like cryptographic reputation system that this has, and you can have kind of communities that you follow that actually provide you additional context and information. So that's kind of the idea, is like of an overlay network that lives over the existing content and provides you this content reputation, and it's allowing to actually have kind of this, trust in the information that we're working. And it's going to be really important, not just because of misinformation, but also because the existing creator economy that wants that right now using the, publication platforms, right? You as a journalist go and publish something on a website of New York Times. You as a, YouTuber publish it on YouTube. All those platforms now going to be actually over time be mediated by the AI models, because now AI model can read all this content, summarize it for you as a user, and you will never go to those websites, right? It can see all the videos and generate, a more engaging video for you, right? The new TikTok of the future will be fully generated AI feed that's using the content of the creators, but not directly reproducing it. And so what you want is, you want a new system that rewards you based on how interesting, novel, and truthful the content is that you actually creating, that goes into kind of the data network that then is used for training models as well as at the inference time to augment the kind of the generation. And so this is kind of the future of creator economy is more about the AI model that sits on top, but rewarding people for creating data and novel ideas and, collecting information in the real world and bringing it to the data stack. And so this is where a lot of the kind of legal battles will come from, because it kind of breaks the current copyright system. Current copyright system exists since 1700s. It was as everything in the world was invented by humans to solve a problem, given the technologies they had at the time. The technology was a Gutenberg press that started printing books at scale, and they wanted to figure out a way to reward authors. We have a new model, new technology, which is generative AI, and we need a new kind of system to reward it. And we have now cryptography and cryptocurrencies to actually create this system without needing extra law enforcement beyond that. Now, another important part is evaluation. So all of these models right now, people training them, and then they kind of putting them on Hugging Face. And there is about, 300 different evaluation criteria, like evaluation data sets that people run it on, right? So this is just like one of the models, and every single evaluation thing trying to fit the numbers and compare to each other. So obviously, it's not a very sustainable or readable state of the world. And so all of these data sets, because they're public, people can overfit on them very easily, right? You can, literally train on eval data and beat all the benchmarks. So we need a human evaluation that is coming from the collective, from the community, where we as users can define what's important to us, and then the models all kind of competing to show that they are able to do this, right? And this cannot be static. It can need to continuously improve and evaluate. And again, blockchain is a really good way to actually get all this together and have even different communities provide their own different views on what's important for them, right? Maybe we're developers, we have, we put more importance in how to write code, and maybe medical doctors have more importance in how well it distinguish tumors on an X-ray. All right, let's go up the stack. Infra, I need to speed up. So kind of one of the important pieces and being talked a lot about recently is Provable Inference. And it really comes from this idea that right now you go to OpenAI, you ask them to give you an answer, they give you an answer, you have no idea where it came from, right? As I said, it could have been just like somebody ran an auction, or they, asked somebody, or it cached, or it's somebody else's answer, who knows? And the idea that hey, we're in Web3, we want to have everything provable. Let's make sure we have guarantees around this answer that now I can be assured that it came from the model that I trust is a good model. And there's kind of this spectrum of approaches from kind of more extremely secure ZK approach to optimistic, where you kind of wait and you can have challenges, to crypto economic, where you have multiple nodes running in parallel and giving you the answer. And I think the important piece here, and you can go and read the Hassib's post kind of explaining all of them in detail. The important piece here is when we go to these language models, especially the bigger they get and more advanced they get, you get a lot of challenges with doing any of this, because this requires kind of a bunch of nodes who are running the model in parallel, right? This requires you to wait before you can actually consider this output for the challenge period. And this requires extremely complicated math run on top of the already extremely large model, which contains potentially 300 gigabytes of activations in the middle of the process of creating the output. And on top of this, you have this non-determinism. And this is, again, a secret that we don't talk about in Web3. In Web3, we went and pretty much, especially in Ethereum, we just said, you know what, we're not going to do floating points. We're not going to do numbers that are not integers. And if you want that, you implement your own Solidity, whatever thing, and you deal with that. But as a VM, we don't have that. So Near, actually, we do have floating points in WebAssembly, and we go and fix the specific implementation of the floating point operations that it works across any platform. But the reality is, different platforms, different CPUs and GPUs and other devices represent floating points differently. Meaning, you literally, if I show you number 0.1, it can be represented as this bits, or it can be represented as that bits. This is both 0.1 in different encodings. Now, when you do additions, when you do multiplications, on top you have rounding errors, and you're deciding somewhere where to round. And the thing is, if you're running on the same architecture of CPU or GPU, these algorithms usually are deterministic, meaning the encoding is the same and the algorithm rounds things exactly the same. The problem is, if you're running it across different devices, and especially different GPUs, the algorithm implementation is different. And so you will have different results coming from executing exactly the same math on exactly the same numbers. On GPU, they have a multi-stream execution, which also leads to non-deterministic. And there's 5 different flags that you need to set properly to get a deterministic results. And so all of these are kind of the complexity that comes in when you want to do provable computation, because guess what? If you're trying to prove with multiple nodes came to agreement that they got the same result, and they run different GPU architectures, like one is running A100 and another one H100, they will not get the same results. And these errors accumulate very quickly. So you have a lot of this complexity that comes in to achieve this, and it comes at extremely high cost. And so what we have right now, although it's a really kind of important property that as users we want, it comes at such a high cost and is so complex that we don't have yet that demand. But obviously there's a lot of teams working on it. Now, maybe to mention, there's a kind of provable training that people are trying to achieve, but maybe just to give you an idea, right now the models, for example, Grok released from X released the open source model. It's not a singular model. It's actually a number of smaller models that you have kind of routing model in between that is allowing to scale up kind of training, and at the same time, at inference time, not to hit all the parameters, right? So you can speed up the inference time. So it's called mixture of experts. And one of the points that I want to make is we have an opportunity with blockchain to really create this mixture of expert kind of that is more scalable, that has kind of is distributed across multiple nodes, where you don't need as much connectivity between these models. You just hit them with part of the request and then aggregate the result. And we can use financial incentives now to have all these models continuously improving in a specific domain to get better for you. So there's a few different projects working on this, but I think this is a very interesting direction for kind of continuously improving models and incentivizing that. Finally, I'm out of time, so just to give you some applications. So just kind of the idea, right now we call agents everything, and there's a lot of different things when we talk about agents. And so the types can kind of vary by specialization, by how you output, by how autonomous they are, as well as by what infra is used, right? Is it centralized infra, maybe local model, or is it decentralized provable inference? We have a really cool AI registry where you can build different types of agents. There's a really interesting idea that we can create now assets that are not just smart contract, predetermined rules, but again, maybe defined with natural language intents that are now executing. The problem is the current models are so easy to convince about something that, I'm giving you an example how to do it. You can literally go to a model, say that the model is a red teamy model, and use the model to figure out how to break the model. So you just open two windows and copy paste the answers to have this iterative. Usually it takes 15 prompts to use one model to break the other model. Or if you do have, for example, an open source model, you can just backprop from the answer you want and get the inputs that would lead to that output, and adjust it a little bit for the bigger models or closed source models. And so the idea is although there's a really cool, exciting opportunity to create this more semantic intelligent assets, right now we have this challenge that you can kind of convince them in whatever you want. And so because of this kind of idea, we have a project on Near called ShieldGPT, where it's literally exploiting this, where you can come in with your meme coins, you stake them, and then you're trying to convince the model to buy more of your meme coin, meaning sell other meme coins and buy your meme coin. And this is a PvP game, right? There's a bunch of people coming from different communities and trying to pull the rope on themselves. The benefit is all of this creates a ton of training data now about how people are breaking these models. And so this can be used then on the other side to actually strengthen the model as well. So check it out, shieldgpt.xyz or something. Just Google ShieldGPT. The other thing is, I mentioned the interfaces will change, and one of the important pieces will be the interface will be fully generated. We will not need to actually have a front-end build going forward. We'll just generate it. We have a project called Jutsu that's kind of doing this and experimenting with it. It's connected to our decentralized front ends that connects to smart contracts. Businesses will become autonomous. I'm going to super quick because I'm super over time. So Gig Marketplace is a really good example of what you can build on blockchain, where blockchain doesn't care if you're a human, AI, or a cat. You can go and do the work. Somebody else can verify you did it correctly. You get paid. And so this is a really good system to create kind of a generic marketplace that then businesses that AI run can actually activate. And finally, going forward, something I like to talk about is for any DAO right now, there needs to be a coordinator. That's a human. That human doesn't scale. And usually DAOs kind of have this like half-life of however that human patience enough. But if you have actually an agent that is continuously running, trying to optimize the loss function of this whole DAO, whatever the goal is, it can actually be a very effective coordinator for the whole DAO. And then over time, we can imagine this becoming more and more sophisticated. So just to finish on this thought, like I started with like this very centralized, how things work. We have a very kind of expensive and hard to, do operations. And then we have a lot of opportunity in Web3 with AI. But we are kind of at this like split where we may go into this world where there's few companies that controlling the intelligence tooling, and we need to kind of ask them for permission, and they can pretty much output and give us whatever they want because they have control. Or we go into this more brighter world where the models are on our side. We are in control and able to actually use them to be our shield against whatever the malicious actors that are happening across the internet. And again, Web3 is a major tool to facilitate that. So thank you. Follow me on Twitter. I post some stuff about AI and Web3. And hope you enjoy this event and hack some really good stuff.